Hello, welcome again to Physics Academy. In this lesson, we will carry on about learning about how to find resultant force by using a parallelogram method. Okay, so we have seen in our earlier lesson, we can find the resultant force by using the triangle of forces. So in this case, we will be using a parallelogram. So what is a parallelogram? So a parallelogram is actually a four-sided shape. A four-sided shape which has two sides parallel to each other. Four sides with two sides, two pairs of sides which are parallel to each other. So we can visualize a parallelogram as in the diagram being drawn here. So this is a parallelogram where these two sides, the two horizontal sides, are parallel to each other, and the other two sides are also parallel to each other. Right? So by knowing this rule, we can also say that a rectangle is also considered as a parallelogram because it has two sides which are parallel to each other and the other two sides which is also parallel to each other. So both ways, they are also known as a parallelogram. So how can we apply this into solving our resultant force? So let's go again with our case that we had learned in the triangle of forces. Let's say there is a box which is resting on the bench. And this box is now being pulled by a force which is 4 Newton in the east direction. And there is a 3 Newton force acting in the north direction. So learning from the triangle method, we know that we have to join the two vectors. So whereas in the parallelogram, the way to do it, it's not by joining the two vectors, it's by starting the two vectors from the same point. That is the important note to be taken here. Important note to be taken here, that you have to start both of the forces from the same point. From the same point. What does it mean by that? Starting from the same point. So let us now draw the whole idea. So since it involves a parallelogram, so what we can do here is that, I'm sorry about this, let us come up with a straight line. Okay. So let us now resolve the forces. We know that the resolution or the solution for this, the resultant force should be equal to 5 Newton. Even though by using the triangle method or parallelogram method, the resultant should not change. So what we have to do here is, since it includes drawing, so you have to choose a scale first. So let us choose, because the values are small, so 1 centimeters represents 1 Newton. So by knowing that, we can draw the first, by choosing the first vector. So just choose any of the first one. Let's say we choose the 3 Newton force as a first vector. So you draw a 3 centimeters straight line, vertical straight line, which is supposed to be pointing to the north, and labeling it as 3 centimeters. And starting from the same point, draw a 4 centimeters horizontal line, which represents to the east, and label it as 4 centimeters. So right now, you just have to complete the whole diagram as a parallelogram. That would mean that by drawing another line, so we can draw it as a dotted line to represent the horizontal line, and draw another dotted line to represent the vertical line. and the diagonal part of the diagonal of this parallelogram will be the resultant force, the resultant vector. So for this resultant vector, we should use a ruler to measure the length. And then use the length that we have measured, compare it with the scale that we have. And then using the same scale of bearing, you can find the direction. So instead of saying using bearing, I would say use a protractor to determine the bearing. Of resultant force. So in the case of bearing, it will be the angle from the 3 Newton force all the way until the resultant force. So we name it theta. So these are the things that you're supposed to follow when you are using a parallelogram method to solve a resultant force. So in this case, the ruler, the length of the resultant, so we can resolve the whole question. So length of resultant will be equal to approximately 5 centimeters. So magnitude of resultant force will be equals to 5 centimeters multiplied with 1 Newton, which is our scale, so it's 5 Newton. And then the direction in the bearing, the value of the bearing in degrees. So that value, I could not use it here. I could not use a protractor here because of my drawing are not basically based on scales. But I'm guiding through my lesson here so that you can use a scale to draw it. So both methods, the triangle method and the parallelogram method, requires accurate drawing. Alright, so you can't be using inaccuracy. Everything drawn here must be accurately drawn according to the scale that you have set. So the scale may change according to the question depending on the value of the vectors that you have. Right? Other than using forces, they can also test using different vectors. So there are other options of vectors that can be used also. That have been asked in a GCSE exam also. Example will be velocity. Number 2 will be momentum. Till up to date, forces are the most common vector question that they will ask in the IGCSE exams, and other than that, velocity and momentum also. So a student must really know that all these are vector values, and vectors can be represented by line and arrows, and the resultant of those vectors can be solved either by using a basic way of solving if they are in the same plane, horizontal or vertical, or if they are in the different directions, then you can use the parallelogram method or the triangle method. So I hope that this lesson will help you to understand the idea of getting resultant forces better. So I will see you guys again in our next topic. Thank you.